Hey everybody, it's Mr. Harrison giving a little bit of instruction to my Algebra 2 students on completing the square. We covered this lesson before this unexpected break, but I'm sure you may have some questions about that worksheet I gave you and how this operation goes. I want to focus on this because it is a very important concept, as I said in class time, and something is used extensively in later math when you get into trigonometry and even in calculus and stuff like that. Excuse me. Cover your cough. Wash your hands. I gave the examples on the worksheet, and I showed all the steps on how to do it, but I figured we might go over just a couple of them that just go over a couple of them. There's number 3 up there. It's already written as x squared minus 6x plus 4. And as I showed in the example, when you're completing the square, first thing you want to do is get anything that doesn't have an x with it to the other side of the equation. So in this case, we'd be moving the 4 from the left-hand side to the right-hand side. How do we do that? We subtract 4 from both sides. So minus 4 minus 4. Our new equation, x squared minus 6x equals negative 4. We're now set up, we're in a position where we can go and work out how to complete the square. As I taught you in class, in completing the square, you always take the number that's in front of the letter x, the coefficient of x. Not the coefficient of the x squared, just the number here in front of the x. For now, I'm not worried about whether it's positive or negative. I'm just going to take that 6. We always divide that number by 2, and whatever we get, we square it. I'm showing that 6 over 2 and squared. Well, 6 divided by 2 is simply 3, and 3 squared is 9. This 9 is what's going to be added to both sides of the equation. You can rewrite it out here and show that work there, or you can just come right back up here and show plus 9 to both sides. If you do this correctly, this left-hand side of the equation is mathematically, what's called a perfect square trinomial. Name doesn't matter. All you need to know is that this will factor into x minus something squared. That could be plus. We're going to determine that here in a moment. Okay? And I asked you guys in class numerous times, what number goes there and how do you know? If you've showed your work here on this line, as I've instructed you to, the number that goes here is always the number that got squared. I look up here, don't put 6 over 2 here. I see that 3 was squared, so 3 goes here. Is it plus 3 or minus 3? When we look at the original equation, since this was minus 6x, this is minus 3. Had that been plus 6x, this would be plus 3. All right? So this left-hand side of the equation is taken care of. Right-hand side, I just need to do negative 4 plus 9. Well, 9 minus 4 is equal to 5. Take away this arrow here so it's not bothering us. I have the quantity x minus 3 squared equals 5. Trying to get the x by itself, I need to take the square root of both sides. Taking the square of the left-hand side, it's not a problem. The right-hand side, I get square root of 5. And do not forget that when you take the square root of both sides, this one is always plus or minus. Still got to get x by itself. X is not by itself yet. I add 3 to both sides, and we get x equals 3 plus or minus the square root of 5. I noticed one of you was doing positive or negative 5 plus 3, a square root of 5 plus 3. Technically, that's not incorrect. That's just not the form we put it in. It's not the order we put it in. So please put it as 3 plus or minus the square root of 5. Number 11, a little more complicated. Number 1, it's we were dealing with these coefficients of x were odd, so when we divided by 2, we got fractions, and that created its own set of complications and things to be dealt with. This one I made it a little bit different because I don't have it equals 0 over there. That's no big deal. We're still going to get x all by itself to begin with first. So I'm going to add 4 to both sides. And that just gives me x squared minus 1x equals 11. Going to complete the square. I'm going to take the coefficient of x. Again, not worried whether it's plus or minus. I'm taking the coefficient of x and divide it by 2. Just like I did over here. I took 6 and divided it by 2, which gave me 3. Well, this is 1 divided by 2, and that is squared. Do not put that as a decimal. Do not put 0.5 squared and then get 0.25. It works, but we're going to stick with fractions right now. 1/2 squared is 1/4. I just want to point out something. Over here, when I was doing the even numbers and I was completing the square, I had 1, 2, 3 numbers. Over here, I have just 2. That's okay. Don't think that you've got to have 3 steps. It's only 2 in this one. This 1/4 gets added to both sides of the equation. Again, magically, this is, on the left-hand side, is now a perfect square trinomial, meaning it will factor into x minus something quantity squared. What number goes there? It's always the number that got squared. I see that 1/2 got squared. By the way, don't put it as x minus 1/2 squared and then the parenthesis. It's x minus 1/2 and then the parenthesis. The squared goes outside. And again, this is minus, so this is minus 1/2. On the right-hand side, I have 11 1/4, which you would want to get a common denominator. Some of them are more difficult than others. This one, not difficult at all, 11 1/4. That gave me, what, 45/4 in proper fraction? Let's just show it. I'm going to multiply this by 4/4. That gives me 44/4 plus 1/4. If you skip that step and just put 45/4, that's perfectly acceptable. And write that like that. Okay? Now I take the square root of both sides. That'll give me x minus 1/2 on the left. Don't forget positive or negative. Square root of 45 over the square root of 4. We're going to clean that up in a minute. Looks like I might be running out of room. As I talk, I'll erase this other equation. Well, I'll just squeeze it in here. So I'm going to have to go to the left side. X minus 1/2 equals plus or minus. I'm going to do the denominator first. The square root of 4 is 2. And the square root of 45, well, if you break it down, that's the square root of 9 times the square root of 5. What's the square root of 9? That's 3, so we get 3 square root 5. Well, now we still haven't gotten x by itself. I'm going to add 1/2 to both sides, and I get x equals 1/2 plus or minus 3 square root 5 all over 2. Some people will write that as x equals 1 plus or minus 3 square root of 5 all over 1 denominator. 6 of one, half dozen of the other. They both say exactly the same thing. They're both perfectly acceptable. And there you have it. So I hope this may have helped clear up any confusion you may have had. There are some that are a little more involved. Give me a call, text me, email me if you have any questions. Hope to see you guys real soon. God bless you all.